Okay, guys, we are going to be talking about how does the tilt of the Earth affect the seasons. And your favorite crash course.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days, and that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Okay. Now, you also, you're going to need your notebook for this, because we're going to pause where we normally pause and talk about different things. Okay.
Hey, Zoe, check it out.
Almost.
No, I can do it. Watch.
Here, let me try.
Sure. Show off.
Hey now, just takes a little practice. Actually, this kind of reminds me of the way the planets rotate.
The planets? Zoe, science class was like 3 periods ago.
I know, but think about it. The Earth just keeps spinning and spinning on its axis.
Yes, you're right. Lucky for us, the rotation of the Earth is like night and day compared to the basketball's rotation on my finger.
That's for sure. And speaking of night and day, you know it's the Earth's rotation that causes night and day, right?
One rotation equals 1 day, right?
Exactly. As the Earth rotates on its axis, different parts of the world face the sun, while others face away. The sun is what gives us daylight. So when a part of the Earth faces the sun, it's daytime in that part of the world. At the same time, on the other side, facing away from the sun, it's nighttime. It takes 24 hours for the Earth to make one complete spin.
That's right. 24 hours in a day.
Uh-huh. And just like your basketball, the Earth spins around an axis. The Earth's axis is an imaginary line from the North Pole to the South Pole, and it's tilted at an angle.
Huh. I didn't know its axis was tilted.
Yeah, and the Earth orbits around the sun.
Sort of like when the basketball spins around the rim of the net.
Yeah, planets orbit the sun, and moons orbit their planets. When a planet completes a full orbit, it equals 1 year, complete with different seasons.
What causes seasons anyways?
Well, it's the Earth's tilt on its axis, along with its orbit that causes the seasons. You know how we split the Earth into the northern and southern hemispheres, right?
Yeah.
Well, as the Earth makes its orbit, different hemispheres are tilted toward or away from the sun. When tilted toward the sun, that part of the planet receives more light and warmth.
Making a warmer season?
You got it! Our summer happens when our part of the Earth is tilted toward the sun, and winter is when we are tilted away from the sun, meaning less light and less warmth. When it's winter here in the US, it's summer down in the southern hemisphere.
Any planets that have one warm, sunny season only?
Aha, nice try. All the planets orbit the sun and rotate on an axis, so they've got the same deal as the Earth. However, there are a few key differences. The length of a day or a year is different for each planet.
Makes sense to me. The longer the orbit, the longer the year, right?
Yeah, and a planet's size and the speed of its rotation can make its day longer or shorter. Like a day on Saturn is only 10.2 hours long. It's huge, but it spins super fast. And a day on Venus is, get this, 243 days on Earth.
What? That's like 5,832 hours.
Imagine that school day.
Yeah, really. There sure is a lot more revolving around this rotation business than I thought.
Totally. Let's see if you can put your own spin on it. Think fast.
Oh, I got this, Zoe. I got this. The Earth orbits around the sun, and the moon orbits around Earth. As it orbits, the Earth is rotating too. It's the Earth's rotation on its axis that causes day and night. As the Earth rotates and makes its orbit around the sun, we get seasons because parts of the Earth are tilted toward or away from the sun. Ha!
Yeah, RJ. Now that's what I call a spin for the win.
Okay. Okay, let's do this test yourself. What causes day and night? Is it the sun's orbit around the sun, the Earth's rotation around its axis, the moon's orbit around the Earth, or the sun's rotation on its axis? Day and night. What are we choosing? Is it around the sun or its axis? I'm just going to pick one. Let's see if we're right. How long does it take Earth to make one full rotation? Rotation, revolution, rotation. 1 day, 1 year, 1 hour, or 1 month? Rotation, not revolution. Take a moment. What does it take the Earth 1 full year to complete? 1 day on Venus, 1 phase of the moon, 1 rotation on its axis, or 1 orbit around the sun? What is the Earth's axis? The path the Earth follows in the orbit around the Sun. One half of the Earth, either northern or southern. The imaginary line from the North Pole to the South Pole, or the imaginary line around the center of the Earth. Its axis. What causes seasons? The Earth's orbit and its tilt causes seasons. The Earth's rotation and its tilt causes seasons. The moon's orbit around Earth causes seasons, or the northern and southern hemisphere cause seasons. There's only two that it possibly could be. Take a minute. Two more. When it is winter in the United States, what season is it in Australia? We talked about this the other day. I said about Australia is when we start summer, they are doing Christmas. So they are in summer. And why are years on some planets longer than years on other planets? Some planets are larger and take more time to spin on their axis. Some planets have heavier atmospheres than others. Some planets are tilted towards the sun for a longer period of time, or some planets take more time to orbit the sun than others. And let's see how we did. Yay! Okay, back to our lesson here. So, in the video, they used orbit. And remember, I kept saying it's rotate and then revolve. So look here, rotate is to spin or to turn. So it's one of my single fingers spinning 365 ways around. It takes 24 hours or 1 day for it to revolve around one thing, which causes the night and the day. However, while it's rotating, it's also revolving, which means it's going around the sun. And that takes 365 days or 1 year. And it causes your seasons. I'm not going to build that little video there, or that little activity. Okay, Bill Nye the Science Guy. Hey guys, Bill Nye the Science Guy. And I'm not quite sure. We'll come back to him. I'm sure we'll definitely be watching him. Earth's equator receives more warmth. The North and the South poles are the furthest from the sun. So why are they so cold? Okay, think about it. Uneven heating. So the North Pole and South Pole have a lot more ice. Correct? So sometimes they're the farthest away. If you look at the tilt that it's at right now, the northern hemisphere right here is facing away from the sun. If the sun is over here, which means they're going to be colder. Where the South Pole over here is a little bit closer. But why would they be so cold? Is the rotation of the planet ever going to be directly on the North and South Pole? They're still the farthest away from the sun. Even if the sun's heating here, look at the distance that it would have to heat here. It has to travel farther here. Now, this is why we have the season change. We have the fall and the winter and the spring and the summer season change. And it's always around the same. If you look here, you have March 21st and 22nd, June 21st, 22nd, September 22nd, 23rd, and December. They're all around the 22nds. That's because we are in a pattern of that rotation of that, or that revolution of that year. Meaning, sorry guys, we just finished the fall equinox, and we are moving into the winter equinox. So also you'll notice that our days will get shorter because of the how we are tilted. We are over here. If you see my mouse, we are over here. So the tilt of the Earth is what's going to cause us away from that. And some more crash course. Make sure you have your notebook ready.
Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at
Average
the graph, we see
temperature,
that during
guys.
December,
Average.
January, and February,
So think about what we
when the
talked
northern
about.
hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing...
Oops. Think about its average temperature. Look, its average is not getting above 86 degrees in Canada. So I thought that was kind of interesting.
Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
So, what do we know about the Earth's atmosphere? And how does this play into what we're talking about?
Whoa, I think I just saw a meteor. Oh yeah, I forgot. There's a meteor shower tonight. We really lucked out. Totally. I've never seen a meteor shower. Wait. Aren't meteors giant rocks flying towards the Earth? What if one hits? No worries, Zoe. Most meteors get burned up in the atmosphere before they even get close to us. The atmosphere protects us.
Protects us? How? It's just layers of air, right?
It's more than that. The atmosphere is the mixture of gases that surrounds the planet. Our atmosphere has 5 layers, and each layer has a different temperature, size, and height above sea level.
5 layers?
Yep. Exosphere, thermosphere, mesosphere, stratosphere, troposphere. They're each held to the Earth by gravity.
Now you'll notice that you'll see those different atmospheres. They are not going to be on the EOG, so you don't necessarily need to take these down, but this will be important later in your upcoming schooling. You will need to know these. Minus thermosphere, they're basically alphabetical. That's how I remember. E, M, S, Q, because S comes before T. But minus thermosphere, they're basically, to me, alphabetical.
Lots of spheres. Yeah, let's move from the outside in and start with exosphere. Exo means outer, so exosphere is easy to remember. It's the outermost layer of the atmosphere. It extends into space.
So exo equals outer, and it extends into space. That's simple. What's next?
Next is the thermosphere.
Therm means heat, right?
Yep, and the thermosphere is known for its great range of hot to cold temperatures. At the inside edge closest to Earth, the temperature is below freezing, but at the top edge, near the exosphere, temps are hotter than 2,000 degrees Fahrenheit.
Now that's hot.
The thermosphere is...
So when you think about it, just like they're about to show you, when they take a space or a rocket into space, it needs to be able to withstand the coldest and the hottest. So that's a great metal that really has to withstand multiple different aspects.
where space shuttles fly, and where we see the beautiful Aurora Borealis.
Aurora Borealis?
Yeah, you know, the northern lights.
Hey, wait. Whatever happened to meteors? Where do those come in?
Actually, you're right on track. Next is the middle layer, the mesosphere. This is where we'll see the meteors tonight.
That's gonna be so cool. I can't wait.
Me neither. In the meantime, let me tell you about the mesosphere. Meso means middle, and like I said, that's just what it is, the middle layer. The air here is a bit thinner.
Cool. So if that's the middle, we've got 2 layers left?
Yep. Next is the stratosphere.
Oh, I've heard of that.
The stratosphere is a pretty important layer. The ozone is here. It protects us from the sun's harmful UV rays. It's also really dry, so there aren't a lot of clouds there. The next layer, the troposphere, is just as important. It's the last layer and the closest to the Earth.
And look how many miles it is.
How close is it?
If you look at it, it's only 6 miles up into the sky.
We're in it. The air in the troposphere is made of 2 important gases, oxygen and nitrogen. Nitrogen makes up 78% of our air.
Can't live without that.
The troposphere is where weather occurs too, and where you'll find lots of clouds. The clouds block the sun's heat during the day and keep the heat in at night. The higher up you go in the troposphere, the lower the temperature you'll find in this layer.
Wow, so that's the atmosphere, huh? Pretty serious stuff, this atmosphere song and dance. It's definitely not just air like I thought. The layers above the Earth are the atmosphere. The layers from farthest out to closest in are exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Each one of these layers has its own unique characteristics. The atmosphere protects us by blocking out harmful rays from the sun and by regulating the temps here on Earth.
Hate to interrupt, but look, the meteor shower is starting.
Okay. And we're not going to do the test yourself because we're just kind of giving you the overall aspect of what we're talking about when it comes to weather and climate, so that when we talk about the weather and we talk about the clouds, you have an idea of where in the atmosphere that they are positioned. Okay. And then after this video here, we'll probably stop for the day, and you'll pick up tomorrow with where we're at.
This layer has all the clouds,
Troposphere life will be found. Sun warms the ocean and ground. I'll tell you, breathable gases in here. Warm sun radiates, this layer gets cold as you move up above, as it turns to the next layer. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed of the sun. Stratosphere, here we come. Planes fly there to and fro. The ozone layer is among. It's got ozone really so neat, blocking some rays like UV. It rises up like a tide. The temperature it will rise. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed of the sun. Mesosphere is cold. Meteors will glow molten, and all your fears will subside. All the meteors will fry. Ionospheres on the list, Aurora Borealis, and the exosphere will disperse, the hottest layer, of course. The atmosphere is why there's life, because the raging suns of fire in the sky. Thanks to the ozone, rays are absorbed of the sun. Thanks to the ozone, rays are absorbed of the sun. Yes, rays are absorbed of the sun.
Okay, and because the next layers of the atmosphere here are the following. You do not need to know this. You just need to know that about how many miles. Here's our ozone layer. Here's our plains. Here's our clouds. Just that the higher you go up, it's the more miles. So look up here. Outer space is over 6,200 miles away. So it's a huge difference. You'll notice that they're closer here. The troposphere and the stratosphere are closer. And then as you get up, they get more and more spread out. So not a big deal. You do not need to write this down. And we're going to stop here, and we'll pick up this video tomorrow. Or if you have more time, then the sub can play the next video, but we're going to stop right here.